Tycho Brahe did a lot of the observations that Kepler used in order to determine Kepler's law. So we want to look a little bit about what he could have possibly seen in some cases. So his angular resolution is reported to be about an arc minute. That's pretty much what you can observe if you're a very good observer, is about 1 arc minute, which is sometimes abbreviated with a little tick mark, one little tick mark, and we know that there are 60 arc minutes in 1 degree, so this is really 1/60th of a degree. That's his resolution. The resolution means what is the smallest angular size that he could possibly see. And this will turn, so 1/60th of a degree will correspond to a different sized object depending on how far away the object is. So an object that is very far away, it'll correspond to a very big object. For objects that are close, it would correspond to a small object. So let's just write down the relationship. We always draw the same picture. So we have someone, who's observing here. They observe some angular size. They're looking at some possible object. This is the actual size, which I'll just call x. And this is the distance to the object. And the way that we do the relationship is we imagine that we are in the middle of a very big circle centered at us, and the radius of the circle is the same as the distance away. And then we do a set of ratios. We say angular size over 360 degrees, that's a full circle, is the same as the actual size is to the full circumference of that imaginary circle, which is 2 pi times the distance away. And this lets us do that. So if we're asked, given the resolution of, say, 1/60th of a degree, how big of an object would he say? Let's say he were looking at the moon. So if you say this is him on Earth over here, and over here he's looking at the moon, we can ask how big of a feature, how big of a rock, or how big of a crater could he see, or how big of a thing. Could he see the moon lander or something like that? That's pretty much what we're looking at. This will give us the smallest object that he would be able to see. Essentially, it would appear to him essentially as a dot, a single colored dot would be what would be at his resolution, and so he can't see anything smaller than that. So the angular size is 1/60th of a degree. Compared to 360 degrees, that's equal to the actual size, and that's what we're looking for, 2 pi times the distance to the moon, which is about 384,000 kilometers. All right, and then all we have to do is say, x is equal to 1/60th of a degree over 360 degrees times 2 pi times 384,000 kilometers. Notice the units, the degrees cancels with degrees, and we're going to end up with kilometers. So that's what the units are going to come out to be, and it's always a good check. And that turns into about 110 kilometers, or about the size of Rhode Island. So the smallest thing that Tycho Brahe would be able to see is something on that order, and which means he could never have seen, for instance, anything smaller than that. So a person with the naked eye would not be able to see, say, the moon lander with this degree of resolution.